look at Q of x, which is equal to x minus 1 all over x. And it says find the vertical and horizontal asymptotes. Now, the vertical and horizontal asymptotes, do you have a question?
Can I move back?
No. No, you're right there. So the horizontal asymptotes occur, these we study end behavior. So end behavior, the indicator is when we let the limit of the function, f of x or q of x or whatever the function is, as x approaches plus or minus infinity. Now that's not the only scenario. And then our vertical asymptotes occur when we have like 0 in the denominator or a negative square root. Okay? So this is a double whammy. So which ones do you want to do first? The horizontal?
Horizontal.
Or okay, so if I look at this function, the lower, so let's write this out. So basically what I want to do is I want to take the limit of x minus 1 over x as x approaches infinity. Now what that means is as x increases, what would happen? So if I were to say g of 10,000, then I would get 10,000 minus 1 all over 10,000. Right?
Yeah.
And that would be pretty darn, it would be 99, it'd be 9,999 over 10,000, which if I rounded would be about 1, right? We all agree that as x gets really, really large, this negative 1 is really kind of insignificant. In other words, if I plugged in 1,000,000, I get 999,000, you know, a bunch of nines all over 1,000,000. And if I were to plug that in the calculator and round, it would round to 1. Well, as we approach infinity, this negative 1 is insignificant. So I'm always going to have infinity over infinity, a large number over a large number, right, which will equal 1. So the polynomial x minus 1 has a leading coefficient of 1, and it's a monomial, but this has a power of 1. In other words, this is a first degree polynomial or binomial, and this is a first degree monomial. So because they're the same, I could also think of it like this. This might clarify it a little better for you guys. What if I said, could I do x over x minus 1 over x? Isn't that the same thing? So what does this become? Well, x over x is 1 minus 1 over x. Now if I plugged in x, that would mean 1 minus 1 over infinity. And what's 1 over infinity? Did we talk about that in here? I have one pizza pie, one round pizza.
Oh, I saw it.
Oh, that's what they call it in Chicago. So,
Chicago?
yeah.
Deep dish. The last city?
Yeah, deep dish, yeah. Meat lovers, whatever. Okay, focus. Okay, so if I take that pizza and I cut it into 4 slices, I have big slices, right? I'd have 1 divided by 4 would be my slices. If I cut it into 8 slices, the slices would be smaller, correct? 1 pizza divided by 8, or 1 over 8. That would be the size of the slice. If I took that same pizza and cut it into 64 slices, what would the size of each slice be?
Not big enough.
Very small. What if I did it and cut it into infinitely many slices? What would the slice size be? 0. This would be 0, right? So what's my limit? 1. So my horizontal asymptote occurs at y equals 1. Maybe. That's an indicator. Now what about the vertical asymptote? So we're going to say that possibly y does not equal 1. Now let's talk about the verticals. The vertical asymptotes only occur when the denominator equals 0. So my denominator is x and it cannot equal 0. So these are my 2 asymptotes possibly. How could I verify that?
Graphically.
I can do it graphically, right? So what I suspect is y equals 1 or cannot equal 1 is the horizontal asymptote. And then I have another asymptote at x equals 0, which is right on the y-axis. X cannot equal 0. Let's see what the graph looks like. So I'm going to come out of here and turn on my graphing calculator. Whoa, that's a lot of stuff there.
Your handy dandy.
My handy dandy calculator. I wore my Blue's Clues shirt today.
You did. Your eyes are
Hey,
pretty.
what's that funny story you want to tell us?
I don't want to tell you. I'm in the middle of doing this problem and I'm recording. I'm not telling any stories. I'm focused. I'm a dedicated math teacher.
Everyone, we should be focusing on pre-calc right now.
Yeah, thank you.
You're welcome. Can I go back to my seat
That's
now?
all of us. No, sit there and be quiet. All right, here we go. So now let's graph it and see what it does. So I've got x in the numerator. I've got x minus 1, right, divided by x, and the graph is this. Hey, look at there. Does it cross 1? I don't know. Let's hit trace. Let's look at the end behavior first. As I approach negative infinity in the x direction, what does my y value appear to look like it's approaching? 1. Very good. Now if I take this and I approach the positive infinity in the x direction, in other words, as I move to the right, what does my y value look like it's approaching? 1. Okay, good. Now, if I come towards 0 from this side, what does it look like I'm approaching? Well, no. Negative infinity. Is it defined at 0? No, there's nothing. It's y equals nothing, right? And the same thing here. So if I graph this, this is basically what my graph looks like. It looks like this, and it looks like this. Was my guesses correct? Were they correct?
Yes.
Yep, that's it. We're done. Bam.
So like freaking.